Hey, this is Don from Padlock Technologies again with another video. This time, as promised, this is going to go into a completely different direction. As I told you guys before, I've been doing firewalls since PIX firewalls, right? PFSense, stuff like that. And this video is going to not be Cisco related this time in terms of the firewall. So before I get into that, what firewalls do I know? So ASAs, FTDs, pretty much expert level there because that's what I was formerly trained on. So now let's talking about the other ones. Palo Altos was actually the first next generation firewall I learned to work on because I was working in certain enterprise environments and they were Palo Altos. And that's what this video today is going to be on is Palo Alto firewalls. Fortinets, worked on those, worked on checkpoints, worked on WatchGuards, worked on Juniper SRXs, worked on Juniper Screen OS. That was uh, pre SRX days. What else do we have? Checkpoints. Forgot to say checkpoints. Might do a video on checkpoints because out of all the next generation firewalls that I've worked on, checkpoints are, if you're coming from the traditional next generation firewall, like if you're coming from Palos, FTDs, and Fortinet, checkpoints, they work a little bit differently, right? In terms of zoning, routing, stuff like that, security policies, how you do certain things. Um, when we talk about firewalls in general, FTDs, they have policies. Fortinets, Palo Altos have profiles, a lot of profiles. Checkpoints have blades. So you activate certain blades that activate certain features. Once you get used to some of the vernacular, it's pretty easy to get around. Now, I'm going to answer the question that's probably in your head. How do I learn all these firewalls? Well, it's very simple. You need to learn next generation firewall logic, right? Because once you know the logic of a whatever next generation firewall, FTDs, Palo Altos, Fortinet, those are the main competitors in the space. If you learn one and you learn the logic of one, you pretty much can, it's very easy to learn the other two, right? Now, do I suggest you be an expert in every firewall in the world? No. You should be an expert in one, proficient in the other. So you should be either expert at FTDs and ASAs and proficient in Palo Altos or proficient in Fortinet. Or you're proficient in Palo Alto and you're an expert in Palo, proficient in Fortinet or proficient in FTD. And if you're an expert in Fortinet, you should be proficient in either Cisco FTDs or Palo Altos. Why? Because the multi-vendor environment is a thing. You're rarely going to get into a space where they're just a total Cisco shop, total Palo Alto shop, total Fortinet shop. Why? Because there are strengths in other platforms that your main platform may not have. Case in point, I'm not really a big fan of Palo Alto's Global Protect. It's great. Don't get me wrong. It's a great solution, but I believe Secure Client is better, right? Especially with all the integration, the ecosystem stuff that's wrapped into Secure Client. Now, if you're a Prisma Access type of person, well, then Global Protect is it's not even a non-starter there. Like you have to have Global Protect for that, right? To actually take advantage of Prisma Access. Same thing. If you are a Cisco Secure Access customer, you're pretty much going into Secure Client. Fortinet has their own thing for their environment, right? So what it really comes down to is what ecosystem you're willing to learn. Now, that's from a sales perspective, right? What ecosystem do you really want to start pushing? Now, from an engineering perspective, you don't get to pick what ecosystem you get to work in. You kind of get thrown into an ecosystem or lack of an ecosystem and you're trying to make things work. So, first step, want to learn a firewall? The first thing you should learn how to do is how do I get the basic internet working, right? How do I create? Because if you can get that done, that means you know how to create objects, you know about security policies, you know about how NAT function works on that whatever device you pick, right? If you can get that, then you start put stacking on knowledge on other features of the firewall. If you can't even get the internet to work on the firewall you pick, you pretty much don't know the firewall at that point, right? So you want to put yourself in a situation where you are going to learn how to, at least at a bare minimum, get the internet up. And that's how I learned all the firewalls. Every time I get a new firewall or there's a new flavor of a firewall, the first thing I say to myself is, can I get internet working on this? If the answer is no, then I have more digging to learn. But if I can get the internet working super fast, then I know this is a firewall that I'm going to learn pretty quick. So, the big diatribe there. What do we got here? So everything in this environment, besides these two firewalls over here, are Palo Alto firewalls. So we have a couple PAs here that are going to be layer 3 firewalls. We have a Palo Alto over here that's going to do a virtual wire. Now, Fortinet calls it the same thing, virtual wire. Cisco's call it inline sets. So we're going to see what's the difference, or what, I mean, difference in terms of configuration, but they pretty much do the same thing, right? They do an inline set. You can create policies on your inline set and you can inspect traffic. Think of it as a bump in the wire kind of situation, right? So then down here is we have a DC1 Palo Alto. Right now, I only have RA so I have Global Protect working on this computer up here is doing Global Protect. Let's just click in here real quick so I can show you what I'm talking about. Wow, that is really, really small. So we go here, we have AnyConnect right here, or not AnyConnect. See, now you see that I've just been stuck in the Cisco world for so long that I'm just calling it AnyConnect. It's Global Protect. And as you can see, I have our I'm about to say FTD. I have our Palo Alto down here that is actually doing radius with ICE, right? Now you can do LDAP, you can do LDAP, but if you have ICE, you might as well use it for your RAVPN authentication. So we have radius already set up here, and if you want to just check it out, we'll just connect real quick. Now, there is a feature on here that I did where you can use Palo Alto FTDs and you have a cookie that can be installed on the machine. Now, your cookie can last up whatever time, say 8 hours. So now when you hit the connect button, you don't have to retype the username and password because it's going to put a cookie on your machine, and then you can just hit connect it and it'll automatically connect it. Now, that's a feature sort of like a always on VPN on Cisco FTDs. But as you can see, I'm connected, right? And if I go into ICE, you see it on the back end here. So if I pull up ICE real quick. Now this is a brand new ICE that I didn't set up for external authentication yet. But again, multi-vendor environments, right? Because you're going to me, ICE is the best NAC solution out there, right? Compared to ClearPass and Forescout and all that other stuff, ICE is still the top of the top for me, right? Now, somebody else might say something different, but we can do a side-by-side comparison of all the features in ICE compared to anything, any vendor out there, and ICE completely blows it out of the water, right? So if we go to our Radius Live logs, we will see that I just authenticated again. So that's my Radius test stuff. But we will see that I just authenticated again. Let me repeat this. Yeah, so here's something I did earlier. I think the cookie just didn't send it, but here you go. Successful authentication with my Palo Alto device, which is right here. PA Palo Alto Firewall is my network device group. Hopefully you guys are seeing that. But yeah, this is just connecting via ICE. And if we go to our network device groups here, just so you guys know that I definitely integrated this with ICE here. Here's our network devices, and the Palo is right. Man, I should make this really bigger than what it is. The Palo is right here. So DC1 PA is right there. Hopefully it comes up. I might actually make this a lot bigger than what it is. There we go. Jeez Louise. So PC1 or DC1, which is Data Center 1 PA, is what I use to authenticate here on this device. So I'm currently connected here. Now, I will tell you this. I don't have a license for the PA, right? So because I don't have the license for the PA, there's certain things that you will not see. Like logging really is limited. You're kind of just limited to this thing called a session browser to see information, right? Now, when you have a license, you get a boatload of stuff that you can view in terms of monitoring and logging and all that good stuff. You get a crap ton of stuff that you can look at, right? Same thing with the FTD. You get a crap run of stuff. Fortinet, you get a crap ton of stuff when you get licensing. Now, where Palo kind of messes up at, and where Cisco kind of beats them is the trial run, right? You get a 90-day license on the Cisco device, right? So you really get to like pick the device apart. Now, I think they have eval licenses on Palo, but Palo, you may want to kind of do the same thing. Like, hey, we're going to give you 90 days to really test this out, right? Because it's an easier sell when someone actually gets to try it, right? And not try it without the limitations or try it without so many limitations, right? From a technical evaluation standpoint. But if it's like, hey, the minute you get this device, you don't have a license, we pretty much lock it down, especially on the panorama side. Um, Give us a 90-day eval of this included of panorama so people get used to panorama because with the panorama license, if you don't have a license, you can't manage a device. Whereas with the FTDs, you have 90 days and you can manage the device. Now there is some limitations, but it's not as much as on the panorama side. So that's where Cisco kind of beats panorama there. Um, so let's close that out. We'll disconnect from just in case you want to see if Global Protect is working. My DC, my AD server is 10.172.11, which I don't know why that's not typing, but 1.1. Oh, forgot the P there. And as you can see, I got complete reachability there, right? So if this machine is not actually joining the domain, so I can't really do an NS lookup for this. But let's just say I'm gonna go to, since we're gonna do an overview of this, we're gonna go in here and actually do a quick overview of what the PA looks like, right? So again, where I'm gonna do a comparison here, the PA GUI is better than the FDM on an FTD. FDM still needs some work, right? In my personal opinion, FDM needs some work. And I know Cisco is working on making that a more usable experience. But as far as like onboard GUI, Fortinet and Palo kind of got Cisco beat on box. On box. Anything else, they're kind of necking, they're kind of like here, right? In an enterprise environment, you're mainly going to see Palo, Fortinet, and Cisco FTDs, depending on who made the sale, but they're pretty much all the same, right? Now they're pretty much all the same now, okay? But from a on box perspective, Fortinet and Palo has the better on box menu. I showed you the FDM. I'll put a little card up here. I showed you FDM. It's usable, but compared to on box of FTD, and Palo, I gotta call a spade here. Like those other boxes have a better on box management feature. Now you connect it to the FMC. I still think FMC kind of blows all the other management ones out of the water. So we got our normal dashboard here. This is kind of like first login information. You can see interfaces with any kind of URL logs, threat logs, tap application, top risk. You can see some general machine information here. You can see system logs, data logs, stuff like that. Now you can get more stuff because obviously, like the FTDs, when you hook them to the FMC, you can add more widgets. So I can add all these widgets to my uh, login screen when I log in, and you can just see more information as soon as you get in there, right? Now, ACC is where you get a bunch of like logs, right? And because I don't have the license, we're not going to see anything here, right? Nothing's going to show up in here. Now, maybe some sample information just so you can get, yeah, nothing, right? Nothing's going to show up. Threat activities, blocked activities, tunnel activities, global protect activities, SSL activities. We're not going to see any of that. Now, I did configure SSL decryption on all the firewalls that I have on the screen or that you've seen because I want you guys to see that, you know what, we'll just test this out, right? So from let's go in here. If I go to NFL.com, we should see SSL decryption going through that PA. So we go here, we go to the connection is secure, and when we look at the certificate, we should see SSL decrypt.plt.com is the certificate. So whenever this wants to show up, come on. Whenever this comes up, we'll see that that is actually the certificate that shows up. But anytime I go to, and actually, I gotta stop using NFL.com because every time I use NFL.com, the certificate takes forever to show. There we go. So as you can see, SSLdecrypt.com, that's usually what I name all my, decryption certs. SSLdecrypt.com. And this is actually, now they call it SSL forward proxy, where FTDs is just an SSL decryption policy, right? Um, so that would be, I'm going to go left to right. So monitoring, this kind of gives you more information. Again, you need a license to see all this, and this is hello, this is a problem. Because if you really want if you really want to sell these things from a technical standpoint, people should be able to see the information, right? See the information without needing a license. Even it should just come with the eval license, a 90-day eval license to allow us to see all the stuff, right? And this is from a technical person standpoint. So these are all the things that you can see in monitoring, threats, URL filtering, data filtering, any kind of stuff like that, tunnel inspection, configuration, stuff like that. Then you can do your packet captures here. Now, packet captures do work a little differently than packet captures on an FTD. Packet captures are pretty simple on an ASA or FTD. Packet captures on a Palo can get a little wonky. Like you can set up certain things, but in terms of ease of use, it's a lot easier to set up packet captures on an FTD than on a Palo if you're seeing it for the first time. Now, obviously, if you're one of those system experts for Palo, you pretty much can do this in your sleep. And I'm taking this from the person that is sitting at a Palo for the first time and they're trying to see what's going on. Um, Next thing, session browser, which I was talking about, is probably the limiting thing that they show you here. Like session browser will show you sessions, right? And will show you if you hit the plus button over here, it'll actually go into the session here, right? Tell you the flow, right? Tell you what it got natted to, all that good stuff. But ACC actually gives you a lot better information compared to this, right? And the virtual system is basically you can cut up a Palo, but those are more on the more expensive Palos, right? So this is the monitoring stuff. From a policy perspective, we got the policy page. So this is where the rubber's starting to meet the road, right? So from a policy perspective, I only got, two policies here. I have one for the internet, one for global protect that you saw um, when I logged into the test machine there to do global protect. This is the global protect rule. Again, if you are used to FTDs or Fortinet, I'm just going to say someone coming from Cisco and you got dumped into a Palo Alto environment, if you're kind of used to the next generation logic, then it's pretty easy to figure out a Palo Alto because they run off pretty much the same logic, not 100%, but pretty much the same logic. Where you're going to get tripped up as is NAT. NAT has really tripped up a lot of people, right? Because the Palo Alto does NAT, it does netting like the ASA used to do pre 8.4, right? So all your netting, especially destination net, is based on the pre-net address and not the post-net address, right? And then the netting will be outside to outside, but the security policy will be outside to the actual real zone. But it's based on the pre-net address. So if anything's going to this pre-net address, once I get in the net and we'll do like a destination net or something, the logic, if you're used to ASAs and FTTs, the logic on Palo Alto, the first thing you're gonna say is, why would anybody do that? Right? But once you wrap your head around the logic, you're like, okay. It still doesn't make it's still kind of wonky, but I can live with it, right? And here's your NAT policy down here, right? So this is just NAT going to the outside. If I was to do a destination NAT, it would say source from the outside, going to the outside interface, going to this pre-net IP address, and then it would have like a destination net, right? So the destination that will convert that pre-net address or to convert that net address or that outside address to a inside address, and then your security policy would be going from the outside to the zone that you're actually going to for that pre-net address. And then it would allow it in. I'm telling you, when we get to NAT on this, or when we do destination NAT, you're going to see if you're an ASA person or FTD person, you're gonna be like, what? Because this is the same kind of net that's on FTD, not FTDs, on Fortinets. So Fortinets do the same thing. So again, if you're coming from ASA FTD world, once we do the NAT, you're gonna say, you gotta be kidding me. QoS is your QoS policies that you want to do QoS stuff for. Obviously, you got your policy-based forwarding, which is just PBR, policy-based routing on an FTD. Your decryption, which is your decryption policy, you can see here, it's called SSL forward proxy, which is an FTE land. It's just called an SSL decryption policy. You need to have a decryption profile, but once you have the certificates and stuff like that, you will, you can do this SSL decryption and be done with it. Tunnel inspection. Most people do not use tunnel inspection unless they want to. Application override, which is just overriding certain application types. Authentication, I forgot what this was again. All I'm doing here is really based off of memory. It's not like I haven't touched Palo in a while, so a lot of this stuff is going to be off of memory. DOS protection is your DOS stuff that you can put on interfaces, but you can see you can just add it here, and then you can have your source and destination, and then your protection options, stuff like that. Um, But again, 9 times out of 10, unless you're really, really carving this up, most environments are not going to use every single feature on a Palo Alto, just like no one's going to use every single feature on an FTD checkpoint uh, Fortinet. No one's using every feature. Now, the one thing that I keep harping on for Cisco point of view is that I like the policy optimizer on Palo Altos, right? So the policy optimizer will say, okay, show me a rule that is unused for 30, 90, or just flat out unused rules, right? So when you have these, this helps in cleaning up a lot of old rules, right? Now I keep telling Cisco they need to have some kind of thing like this kind of policy optimizer where I can click a button and say, show me all my unused rules. Show me rules that haven't been used in 30, 60, and 90 days. Cisco, you got to do that. All right. Because that's going to allow me to actually clean up my firewall. Right. If I could just instantly click and get the rules that are not been used in 30 days, then I can, do some firewall cleanup. But if I have to use last hit count, well, that doesn't really tell me anything. Again, this is why I say, you know, let me just be honest, just steal. Sometimes you just gotta steal stuff. If it works, right? Steal it, right? It works over here, put it over here. It is what it is, man. I'm pretty sure they stole stuff from you. It is what it is. Right? Right? You got user ID, which is realms on FTD. You got app, which is, your app ID, which is application or Eve, right? And then you have content ID, which is your URL filtering and all your data your, like data types and all that good stuff. Everybody steals from everybody, right? When it comes to this firewall technology game, they just call it something different. So let's go. Get on this, man. I need the 30, 60, 90-day option. All right. Now I'm going to get off my diatribe because I still love you guys. Then we have our objects, right? This is where rubber meets the road for everything. Now, in Palo Alto, everything is a profile. It's a profile with some options configured in it, right? Again, profiles are in Fortinet and Palos, and then FTDs, they're policies, right? Malware policy, identity policy, SSL decryption policy, ZTNA policy. would technically be a profile in the Palo Alto world. Right now, your security profiles, and this is the one I'm really going to tell you about, which is the security profiles, which is basically policies, right? So you want to do file blocking, URL filtering, antivirus, anti-malware, wildfire analysis, which is technically in a Cisco, from a Cisco standpoint, that is your cloud lookup kind of thing, right? So if you have like secure endpoints for networks or just for just endpoints, and you got to integrate it in FTD, and you want to do like a cloud analysis, dynamic analysis. That's what this wildfire is. They just call it wildfire. Data filtering, DOS protection stuff. Then you have your custom objects, which you can have your custom data patterns, custom URLs, hip objects, which is hardware. I forgot what hip was. And I know somebody from Palo is going to kill me when they say you forgot what HIP is, but this is sort of like a host scan on ASAs or FTDs, which was pre posture. So you can check certain things and say, hey, if this is not in the profile, we're going to use this HIP profile to posture a device before we allow it on the network. That's why it's under Global Protect. I use tags a lot because I can make tags, and this is a cool thing here on Palo Alto's. I can make tags for a network, right? So I said DC VLAN, 172, and then I can go to address groups and then create a dynamic group or add things dynamically to a group based on the tag value. So if we go up in here, DC networks, you see I'm matching this tag and it's set to dynamic. I'm matching the tag DC VLAN 172. So anything that I add in there will automatically get added to DC networks. And then if I go to this address here, you see it's blue. So I tagged it in DC1 VLAN 117. So if I add anything to that tag, it automatically adds it to the group. And then I can use the group to do some kind of policies on stuff like that. Right. So that's pretty cool. I'm not even gonna sit here and lie. That's a pretty cool thing that you can use. All right. Um, from a network perspective, this is where you start configuring your zones, your interfaces, your VLANs, your virtual wires, your virtual routers, which are basically VRFs in FTD land. All right. IPsec tunnels, GRE tunnels. I don't really do DHCP too much, but then you have your network profiles where you can pick your, phase one and phase two protocols. If you're doing your site to site VPNs, you can do interface management. This is sort of like what's on at Fortinets, where you can configure, hey, you're allowed on this interface. You can do SSH, you can do HTTP, stuff like that. You have your QoS profile, BFD, which is bidirectional forward detection. If you're gonna do OSPF and you want to do BFD on top of that, you can do that. But here's the interfaces. I only have two on the PA1 firewall, and as you can see, these features are my Global Protect features here. Layer 3 interface. I got an interface management or management profile, just ping only. It's in my default virtual router, and here's my security zone. Same logic as FTDs and Fortinet. That's why I'm gonna keep stressing. Hey, if you know an FTD, if you know Fortinet, it's pretty easy to learn the other ones, right? Because they kind of go off the same logic. I would say like 80% of it is the same logic. It's the 20% that's that vendor specific implementation, right? But if you know 80% of it, you can figure out the other 20%. It's not that hard, as long as you know the logic. Then we have our tunnel interfaces, which I'm using Global Protect on. I can also do tunnel interfaces for site-to-site VPNs, which are all route-based. PAs and Fortinets, well, PAs and Fortinets do not have crypto map style, right? That's Cisco specific crypto map, old legacy style VPN, right? But now the FTD does route-based as well. But Palos and Fortinets are route-based. Right, if you're doing Palo to Palo, it's mainly route-based VPNs. Loopbacks, VLANs, if you want to clear VLANs, you can do that as well. And then you have your SD-WAN capabilities as well. Then you have your zones. Obviously, I only have 4 zones on here. Now my I haven't created a site to site yet. So when I do, it's going to be under the site to site zone, but it's the same logic. You can tell it what type. 9 times out of 10 is going to be layer 3. You could have layer 2 if you want, but 9 times out of 10 is going to be layer 3. Now you're going to see this user ID that's enabled here because that is how Global Protect, you can put the username and password in there. If you don't do user ID, it's not going to work. So if you do Global Protect, you do have to enable this. I don't have VLANs here yet. Didn't do that. Don't plan on doing this, but you could create VLANs if you want. You want to do VLAN interfaces, you can do all that, but I haven't created that. Okay. So don't worry about that too much. I haven't really seen people using that too much. Virtual wire, this is your inline set, right? This is going to be your inline set. So basically what you would do is hit add, and then you would add your 2 interfaces, whatever those interfaces are, but you would need to go in here. Let's go to interfaces again. I'll just use 3 and 4, even though 3 and 4 is not there. So you'd have to change these interfaces to virtual wire. So let's say that, and I will give it, I didn't create the virtual wire yet, but I'll give it a virtual wire interface. And I'll say 4 is a virtual wire interface. Now, I didn't give it a security zone yet. Not really worried about that. But let's go to your virtual wire, and now it gives me the ability to pick an interface. All right, because I set it to the virtual wire. I'll leave it for now on this, and then when we get to the virtual wire section, I'll show you how to create a virtual wire. I kind of showed you it right there, but we'll get to that. Then virtual routers. Again, you can create multiple virtual routers and put separate interfaces in them, and they're technically 2 separate routing tables. So they won't be able to see each other unless you leak from one virtual router to the next. All your interfaces are going to be in that, whatever you put, right? Then you have your static routes. I have a bunch of static routes here. You got a redistribute profile because I am doing OSPF on this. So I'm going to redistribute the static route or the destination there. And then we have OSPF. I have OSPF configured. You have area 1 or area 0. That's the interface. Then we have this export rule to redistribute as an E1 that route. So if I go back to here and we go into this and I go show IP route OSPF, I should see an E1 route, which is right there. All right. Which is right there. Should be the E1 route. We also see some static routes in there, right? So these are the routes that are coming from my global protect. And then if you actually want to see what's in the routing table, you just hit this more run stat here. And then this is actually the routing table, right? So this is the routing table that you would see. Now you can do by CLI if you want, but if you're in the GUI, you might as well just do it now. What else is there quickly that we do? So that's the networking piece. This is how you set up on the networking. And then last but not least, we got the device stuff, which is device specific things, right? So we have your management, we have the services. Now services, the service route configuration is by default use the management interface, but you can actually go in here and change, and that's what I did with Radius. You can change the interface that a certain service is coming from. So what I did was the Radius one, because I configured the NAD using, or the NAD in ICE to use this address. So I had to change it so it doesn't come from the management address, or Radius wouldn't work. Management here is basically just exactly what it sounds like. You can set up some management functions here. Um, I don't see a lot of people playing around with this. Some people do. And then you have Panorama when you want to set up an FTD to go to Panorama, sorry. You would set it up here as well. Now your HA is not configured because this is a single FTD. Oh my God, why do I keep saying FTD? This is a single PA. So you don't have HA here. Now HA works a little bit differently because the device priority is the lowest priority, right? But you can do a lot of device specific things here. Now, the one thing I have here is my certificates, and this used to trip me up as well. Certificates, when I first learned to do this on the PA, um, it is totally different from the FTD, obviously. But if you, when you export the certificate, if you import it as a different name, it does not go to the certificate that you did the CSR for. So you have to, whatever you name it here, you have to rename it the same thing when you import it, right? So you have to use the same name. That tripped me up for like 15 minutes because when I first learned to do it, it never specified, hey, when you re-import this thing, you better use the name of the CR you better use the name when you configure the CR, or it'll just show up here as not valid. Then we have our radius stuff, which is our, again, a radius profile. I haven't done TACX yet, so I'll do TACX a little later. We have our local database and stuff like that. Now, that's the single PA. Now, the one thing, let's commit here. Now, the one thing again, Cisco, I've been harping on this for years here. The ability to cancel deployments. That's still not in the FTD, and I don't know why. You know how many times we had to sit here and wait for the deployment to either time out? Well, I've been, you know, at Cisco's neck for years now saying, hey, we need the ability. Now you can use this thing called OmniQuery from a CLI perspective, but to try to use OmniQuery, it's such a pain to use that. But the fact that I have the ability that when I hit the commit status to hit cancel if I don't want to commit it, I think that feature, of course, this stuff is going to come up because I'm not. So basically, what this warning means, the tunnel interface is not going to use IPv6, and the forward, I didn't check forward or decrypt untrust certificates, so it's going to just bypass that, right? Or it's going to use the uh, decryption option that I picked for the certificate. The default one was like forward trusted certificate, so it's going to use the same certificate. That's all that's saying. But the ability to cancel a commit, right? I need to cancel it right away. We need that feature. I think every firewall should have that feature. Every next generation firewall should have the ability to cancel a commit if I don't want to commit it, or if I make a mistake, or if I forget something. I need to be able to cancel the commit. That waiting for it to time out and that that is useless, right? It should always be, hey, I can cancel this when I need to cancel it. So that is a single PA. Now I'm going to show you, I have back over here, active passive or active standby and active active. So let's talk about active active real quick. Active active, I have a love-hate relationship with Palo Alto's active active, right? Now on the ASA, active active was VLAN based load balancing. You couldn't use the same VLAN if you're going to do active active on the ASA. On an FTD, active active does not exist. Okay. Just like multi context doesn't exist. Active active doesn't exist in the way that it used to exist on the ASA. Now, active active is technically clustering on the FTD, right? Now, clustering is way better on an FTD compared to Palo Alto. Sorry, Palo, you lose on clustering, right? Clustering is, you have your owner, director, and forwarder, right? Palo Alto's works a little differently, right? And plus, it's one master configuration. So whatever you configure on the master FTD replicates amongst all the FTDs in the cluster, and you can have up to 8. Palo Alto does not do that, right? So it's active standby. It just, it takes the configuration from the active and syncs it over, right? On active active does not do that. So they have two methods of active active. So they have floating IPs, which I do not like. That's one active feature I do not like. So what floating IPs is you configure an IP address, right? And you can configure it on both FTD. If I say FTDs one more time, you can configure it on both Palo Altos, right? and they could be different IP addresses, and then you would configure the default gateway to its respective Palo Alto. Now, if one of the Palo Alto goes down, the other box takes over the floating IP for the failed unit, right? So a Palo Alto can technically have like two or three floating IP. Well, technically two. Let's just say two. It can have two floating IPs on it, right? It can have its own floating IPs and then the floating IPs from the other PA when that failed. I do not like floating IPs at all. I'm like, this is pretty much useless at this point. All right. Now, and if you look at the documentation, they actually show you the picture of that. They'll have two Palo Altos with two different floating IPs, and they're like, okay, well, one fails, it will just move the floating IP from the failure to the other box. And I'm like, well, then what's the point of just I don't need to configure two floating IPs at that point. Just give me one floating IP and it just moves over to the other box, right? But if it does that, you're not really doing active per se because one box is always answering for the floating IP. The other one is called ARP load sharing. Now, ARP load sharing kind of works like HSRP and VRRP, right? You'll have your internal links will share or load balance a specific IP address between the two. Think of it like HSRP or VRRP, right? But you can't really do that from the outside on ARP load balancing because you can't net to that IP address. Dynamic net is not allowed. So dynamic IP import option for net is not allowed when you use ARP load balancing on the outside, right? So I only use it on the inside. So basically, right here, I have this 192, the ARP load balancing IP, right, for the active configuration is only using it on the internal interface, right? So the LAN interface. So my IP address is 192.168.25.1, and I have a static route pointing to that. But on the back end, there is no there is no load balance IP. So from a NAT perspective, you'll see two NAT rules and you have to bind them to its respective PA, right? So I'm gonna first show you the active standby, which if we're talking about design, you don't really need to use active, right? For the most part, most people have no real need to do active at all, right? Because you can get some asymmetrical issues, routing issues. You get these weird L2 problems if you have like active with virtual wires. You can get weird issues there. So most people you don't really need active for the most part. Special situations you may do, but those special situations are few and far between. Now, as you can see with the active passive, you see active passive, right? You don't really see, you'll see something different when we get to active. And when you get to that configuration, I'm only going to show you the HA part. Here's the HA part. So I'm using two interfaces. I'm using ETH1.2 and ETH1.3. You will not see the H3 interface that is exclusively for active and not active passive, right? And then they pretty much do their syncing, and then once you sync up the configurations, everything you do is on the primary, and then it just syncs over to the secondary. If links go down, now I didn't do a link policy yet, but to say links go down, it moves over to the secondary, and then everything is working like it normally would, right? No issues. You only have to worry about one IP address on each side. Now let's look at active. So active, and you notice I have two PAs up because it shares the routing, but it doesn't share the interfaces. So we're gonna walk in here. We're gonna log into the active primary. Now that vernacular I just used is a little different. Active primary and then active secondary. So here's the active secondary. So as you see, I named it HA AAPA. So high availability active PA1. Uh, I wish they would really stop doing it with these little fish stuff. FTD does it too. Like they want to go, welcome to these new features. Like, dude, once I say close the first time, don't show it to me again. So as you can see, we have the active primary and the active secondary, which is this box here. They're both active. They're just primary and secondary from a priority standpoint. So what you'll notice is if we go to network, you see my interfaces, right? So we have this 25.2, 10.2. We go the same thing over here. We have 10.3, 25.3. So they're not taking the interface configurations at all, right? You have to still go in here and at least configure the interface configurations. What does it take? The router, right? So anything I configure on the primary from a routing perspective, I did a bunch of static routes for this. It does automatically come over on the secondary. If I do something from a policy perspective, it does automatically come over on the secondary. If I create a certificate on the primary, it will take that certificate and put it on the secondary. But if I change routing, like this is where you got to be very careful because because it takes the routing, if I create a default route going to a certain IP address on PA1, it will also put that static route on PA2 as the default route. So these situations, usually what you're going to do is you're going to have it in the same subnet and say we're going to the same default gateway. You're not going to try to do, hey, go to, you know, PA2 is going to go to a different route. So here we go right here with this static route. I'm saying go to this next hop, right? There's no from what I see, there's no way you can bind this to a PA by itself. So they're going to share this routing information. So just design it right. This is where designing it right is going to help you. If you don't design it right, this is bound to fail from the beginning. What else is there from a policy perspective? So net, let's go. So net, now when you do active, one's going to be 0, one's going to be 1. So as you can see, this net rule, right? And it's specifically going to, this is going to 1. So if we go in here, this is going to PA1, right? So since this is going to PA1, I could technically go in here. We would go to translate the packet. I did it by the address, but since I could just do interface address, PA1. Now, because this is not bound, you see how it went to PA, you see how it went to E3? I'm gonna cancel that. And let me see what's on this one. Nope, we don't want to do that. And do interface. I'm gonna go here. Let's see if it changed anything. Yeah. This is why I had to use the IP address, right? And not the interface. I had to just bind it to the IP address and say, hey, you're going to go to PA1, you're going to go to PA2. This is on the net, right? But security is, there's no binding in security. They just take the security rule and just go from there. The NAT rule, though, gets bound to its respective PA. The other thing, there is a thing called um, a session owner and then a setup device. So the session owner does the 7 stuff, right? 4 through 7. I'll say the layer 7 stuff, the app ID, the content ID, stuff like that. The setup device will do 1 through 4, the routing, the NAT lookup, and all that good stuff. That's another weird logical thing with PAs. And the last thing I'll show you here from a HA perspective is here's the HA configuration. As you see, I got it set up as active. Active. This is the secondary because the priority is 100. The other one is 99. We have the HA communication, which is the links that you're going to use. So I'm using ETH 1, 1, 2, 1, 3, and 1, 4. This is what's doing the syncing because you need to have 1, 4. You need to have a third link for this. Our HA3 link needs to be there. I did set up a link. I think I did a link setting in this. Or probably not. because I just turned this on. And then we have the active configuration, which is the ARP sharing interface, right? So I'm technically pointing my next hop to this IP address, and it's load balancing between the two PAs. Now, if I wanted to do a floating IP, which don't want to do that, but I'll show you what it looks like. So if I go to, that's the internal. If I wanted to create a floating IP, I would do floating. And then you would set, okay, PA1 either owns it because of priority, or PA2 owns it because of priority. And again, I don't really like floating IPs, but it's an option. So that is PAs in a nutshell, right? I kind of did a brief overview of a lot of things. So watch this video again. If you missed out on anything, just watch this video over again. We have a single PA that's going to be for my site-to-site VPNs, my data center traffic, and my global protect that we kind of already saw. We have a active standby PA setup just to show you what that looks like. And then we have an active setup that's actually going to do my internet traffic for, let's go here. I'm going to do the internet traffic for building 1 and building 2. And then this PA, this active passive setup was just to show you from a OSPF perspective how you do OSPF. So if I look at my OSPF, let's look at show OSPF. Database internal or external, we have our routes here. Show OSPF database. I'm just going to do database here. All right. So we have one route coming from 26, and it's a metric type 1, I believe. And it's coming from this PA here, which is 26.1. So it's coming from the primary. All right. Which is, where are we at here? Trying to find it. Here it is right here. Yep. And it's a metric type 1. But because I have a static route with the tracking object, by the way, so if I do show track 1, have a tracking object that is up. Now I can do show track 1 brief, gives me a better output, a little bit briefer output, but I do have IP LSA, it's doing ICMP echo, it's doing reachability, and the tracking object get up. So that means my route will always be there until the tracking object goes down, then it'll flip over to the active passive, right? So if I shut down interface, VLAN interface on the SVI 25, eventually that track object is going to fail, and then the OSPF route will kick in, right? Because it'll remove the static route because the tracking object is failing. So that is the PA overview in a nutshell. Now we will do some deep dives into certain topics. Again, I'm proficient in PAs. I'm not an expert in PAs like I am on ASAs and FTDs, but I'm very proficient on PAs. So we'll be going over a couple things, couple features in the PAs. So I hope you really enjoyed those videos. If you have any questions, there's going to be a video bumper at the end of this video where you can send your questions. It's going to be request a vid at padlock.com. Hope this video was informative. Don't forget to share, comment, like, and subscribe. Look out for the next video. Thank you. Have a nice day.